The reading came in on a Tuesday, not with a flare or a rupture or a column of ash. It came in as a number, a temperature index, a fraction of a degree above a baseline measured against decades of prior readings, and the agency that tracks it quietly moved its alert status from neutral to watch. That is how the Pacific Ocean announces itself. Not with drama, with arithmetic. What the National Oceanic and Atmospheric Administration confirmed on the 14th of May 2026 is this: an El Niño is forming. The probability of its arrival between now and the end of July stands at 82%. The probability that it will still be present and active through the winter of 2026 into 2027 stands at 96%. Those are not projections from a single model. They are the consensus of the North American multimodal ensemble, the combined output of multiple federal and international forecasting systems, and they are aligned in a way that forecasters describe as unusually consistent. A consensus at 96% is not a probability. It is a statement about what is already in motion beneath the surface of the water. This is not the first El Niño in the record. It is not the second, nor the 10th, nor the 30th. The cycle has been observed, documented, measured, and named for centuries by the fishing communities of Peru, who noticed that warm water arrived around Christmas. They called it El Niño, the boy, the Christ child, a name that has persisted into an era of satellites and deep ocean floats and orbital buoys that can read the temperature of water 1,000 feet below the surface in real time. What is different about this one is the baseline it arrives on. The ocean that is warming right now is not the ocean of 1997. It is not the ocean of 1983. It is warming on top of a global mean temperature that is already running approximately 1.3 degrees Celsius above the pre-industrial baseline, which means that everything this event generates, every drought, every flood, every shifted monsoon, every displaced storm track, will play out in a climate system that has already moved significantly from where it was when the last great El Niño arrived. The textbook patterns still apply. The models still recognize the signatures, but the amplitude of what follows may not look like the textbook. Tonight's report covers the specific data NOAA has filed. It covers the 6 consecutive months of rising subsurface temperatures in the equatorial Pacific that preceded this watch declaration. It covers what the instruments currently read, what the models agree is most likely to follow, and why the monitoring window between now and June 11, the date of NOAA's next formal ENSO diagnostic discussion, matters in ways that most coverage is not fully articulating. And then we go further, because the record does not begin with NOAA. It does not begin with satellite buoys or Argo floats or the global ocean monitoring grid. There's an older file. There are traditions from the Andean coast where this phenomenon was first named, from the river valleys of ancient Mesopotamia, from the ceremonial calendar systems of pre-Columbian Mexico, and from the deep ocean cosmologies of West Africa, that each documented what happens when the sea changes its temperature and the sky follows. These are not vague parallels. The language in some of these accounts is specific enough to be notable. We will get there, but the data comes first, and it needs your full attention because there is a number in tonight's NOAA file that no major outlet has flagged. We will reach it before the first section is done. If this channel and the kind of reporting it files are what you look for at the end of the day, the slow, cross-referenced account of what is actually in the record from the agencies and from the older human archive, then subscribe. The Bureau files every night. It does not wait for the big headline. The small number is sometimes the one that matters more. And tonight, before we go any further, we want to know where you are watching from. Drop your location in the comments. The pattern we are about to report is planetary in scale. The data looks different depending on which coast, which latitude, which agricultural zone you are standing in. Tell us where you are. Tell us what the sky has been doing. The report is about to begin. The briefing starts now. On the 14th of May, 2026, at 11 a.m. Eastern Time, NOAA's Climate Prediction Center issued its ENSO diagnostic discussion and formally declared an El Niño watch. The status change from ENSO neutral to watch is not a casual administrative step. It is the agency's official acknowledgement that ocean and atmospheric conditions have crossed a measurable threshold, one that, historically, precedes a confirmed El Niño event more than 8 times out of 10. Here is what that number means in practice. NOAA tracks sea surface temperatures across 5 distinct regions of the equatorial Pacific, designated Niño 1 plus 2, Niño 3, Niño 3.4, Niño 4, and Niño Western. The index that matters most to forecasters is Niño 3. 4, a rectangular slice of the central equatorial Pacific running from 120 degrees west to 170 degrees west, 5 degrees north to 5 degrees south of the equator. When temperatures in that region exceed the 1991-2020 average by 0.5 degrees Celsius or more for 5 consecutive 3-month periods, NOAA officially declares El Niño conditions. As of the week ending the 24th of May, 2026, the Niño 3.4 index stood at plus 0.4 degrees Celsius. The Niño 4 region further west in the Pacific stood at plus 0.5 degrees. The Niño 1 plus 2 region, closest to the South American coast, stood at plus 1 degrees. That last number is the one that has not been prominently reported. A Niño 1 plus 2 anomaly at plus 1 degrees Celsius in late May, at the early phase of a developing event, is a leading indicator of pace. It suggests the eastern equatorial Pacific is warming faster than the central index alone would indicate. We will return to what that pace implies before the end of this section. The subsurface picture is, if anything, more significant than the surface readings. Beneath the ocean surface, in a layer that oceanographers call the thermocline, the boundary between warm surface water and cooler, deeper water temperatures have been rising for 6 consecutive months. The depth of the 20 Celsius isotherm, which is the standard proxy oceanographers use to track how far down the warm water extends, has been pushing progressively deeper across the equatorial Pacific since late 2025. What this means in mechanical terms is that there is an enormous reservoir of warm water sitting below the surface, propagating eastward along the equatorial waveguide, driven by the same dynamics that cause what oceanographers call a Kelvin wave, a wave of warm water that travels along the equator constrained by the Coriolis effect. That warm water mass does not simply dissipate when it reaches the surface, it fuels it. The surface warming that NOAA is measuring right now reflects, in part, warm water that has been building in the subsurface for months. The pipeline is not empty. There is a number associated with the depth of that thermocline anomaly that has not been cited in any mainstream outlet's coverage of this watch declaration. We will reach it. The atmospheric component is beginning to follow. In a fully developed El Niño, the surface temperature anomaly in the central Pacific disrupts the Walker circulation, the east-west loop of air movement across the tropical Pacific, driven by the temperature gradient between the warm western Pacific and the cooler eastern Pacific. As that temperature gradient weakens, the trade winds that blow westward along the equator weaken with it. Westerly wind anomalies, anomalous winds blowing east rather than west, begin to appear over the western and central Pacific. As of the May 14 report, NOAA's Climate Prediction Center documented exactly this pattern. Westerly wind anomalies were observed across parts of the western and central equatorial Pacific. Convection, which is the organized thunderstorm activity that normally clusters over Indonesia and the western Pacific warm pool, had begun to suppress and shift eastward. These are not subtle signals. They are the recognized precursors of a transitioning coupled ocean-atmosphere system. The International Research Institute for Climate and Society at Columbia University, which runs its own ENSO probability forecasts independently of the CPC, published its May assessment showing El Niño conditions likely to persist through the remainder of 2026 at a probability that its own models place consistently between 97 and 98%. The IRI's dynamical and statistical model Plume, the ensemble of forecasting models the Institute uses to generate its probability estimates, shows near universal agreement on the event's continuation through the Northern Hemisphere winter. That level of model agreement, particularly in May when ENSO forecasts are historically less accurate, due to the so-called spring predictability barrier, is not common. The models are not divided on the direction of this event. They are divided only on its eventual intensity. That intensity question is the critical one. NOAA's CPC assessed the odds of the event reaching strong or very strong status. Niño 3.4 anomalies above 1.5 degrees Celsius at approximately 65% by October 2026. The agency described roughly equal odds, around 25% each, of a very strong, or moderate event, peaking in the November 2026 to January 2027 window. The last very strong El Niño on record was the 2015-2016 event, which produced the highest Niño 3.4 anomaly in the modern instrumental record at its peak. The 1998 event, which preceded it as the prior record holder, caused an estimated $35 to $96 billion in damages globally, displaced approximately 1 million people in Latin America, triggered a drought across Indonesia and Australia that burned an estimated 9 million acres of forest, and was linked to widespread failure of the anchovy fishery off Peru, the same fishery whose periodic collapse first gave this phenomenon its name. If the current event tracks toward the strong or very strong end of the forecast distribution, the context, it is operating in a global baseline temperature already elevated by over a degree, means the effects will not simply replicate 1997. They will play out on different ground. There is a third layer of data that contextualizes all of this. In April 2026, a peer-reviewed study published in the journal Earth's Future by Annie Cazenave and colleagues at France's Lagos Laboratory found that an anomaly in the rate of global sea level rise, an anomaly that had puzzled oceanographers for several years because the observed rate of sea level rise was exceeding what surface melting of ice sheets and glaciers could account for, is explained by deep ocean warming. The deep ocean, below 700 meters, has been absorbing heat at a rate that has accelerated beyond what the prior generation of monitoring could detect. That accelerating deep ocean heat uptake is changing the density of the water column, which expands the volume of the ocean from below, contributing to sea level rise in ways that are not immediately visible at the surface, but are measurable in the satellite altimetry record. The El Niño that is forming right now is not the only thing warming the Pacific. It is one thermal signal superimposed on a broader warming trend that extends all the way to the ocean floor. Hold that in mind. The number we have not yet named, the subsurface heat content anomaly in the equatorial Pacific, measured in units of zettajoules, will be relevant when we reach the historical record section. For now, here is what the monitoring picture looks like as tonight's report is filed. The weekly Niño 3.4 index is at plus 0.4 and rising. The Niño 1+2 index is at +1. Subsurface temperatures have risen for 6 consecutive months and remain anomalously warm. Westerly wind anomalies are present. Convection is suppressing near Indonesia. The North American multi-model ensemble is aligned. The International Research Institute's models sit between 97 and 98% on continuation through winter. The next ENSO diagnostic discussion is scheduled for the 11th of June, 2026. That is 12 days from tonight. The briefing that comes out of that discussion will either confirm that El Niño conditions have formally arrived, or it will describe what caused them to stall. The agencies are watching the same signals we just reviewed. What they have not connected to the current data, at least not in any public communication, is the historical record of what happens when this same pattern has been observed before. That record is what comes next. We want to extend the briefing section's treatment of the instrumental record because the specific monitoring architecture that has been built around El Niño since the 1982 event is itself a remarkable piece of human response to a recurring planetary disruption, and understanding how it works makes the current watch declaration more legible. The Tropical Atmosphere Ocean Array, known as the TAO Array, was conceived in the aftermath of the 1982-1983 El Niño, precisely because That event had demonstrated that the existing monitoring infrastructure was inadequate. The event had developed largely undetected until its consequences were already materializing. By the time scientific consensus acknowledged the magnitude of what was happening in the Pacific, the drought had already begun in Australia, the floods had already struck Ecuador, and the anchovy fishery off Peru was already collapsing. The TAO array was the response, a network of moored buoys placed across the equatorial Pacific at regular intervals, each continuously measuring ocean temperature from the surface down to several hundred meters, as well as surface wind speed and direction. The first buoys were deployed in the mid-1980s. The array was substantially complete by 1994, just in time for the 1997 event, which, unlike 1982, was detected at its earliest stages and predicted with reasonable accuracy several months before its peak. The improvement in detection between 1982 and 1997 was not incidental. It was the direct result of the monitoring infrastructure that the 1982 event's consequences had made politically possible to fund and build. The TAO array now comprises approximately 70 moored buoys spanning the equatorial Pacific from 95 degrees west to 137 degrees east, a linear distance of roughly 13,000 kilometers. Each buoy transmits data in real time via the Argos satellite system. The data feeds directly into the NOAA Climate Prediction Center's operational forecasting models. When the weekly Niño index updates appear on Thursday afternoons, they are drawing on this continuous stream of real-time ocean observation. The number that went into tonight's report, Niño 1 plus 2 at +1, 0 degrees Celsius, came from a buoy sitting in the eastern equatorial Pacific that has been recording temperature continuously for decades. That buoy has no ideology. It has no narrative. It has a temperature sensor and a transmitter and a record that goes back 30 years. Alongside the TAO array, the Argo float program provides the subsurface picture. The Argo floats are not anchored. They drift with the currents, programmed to descend to a parking depth of 1,000 meters every 10 days, and then sink further to 2,000 meters, measuring temperature and salinity as they descend, before ascending to the surface to transmit their data and receive new instructions. The 3,900 plus floats currently deployed in the global ocean collectively create a three-dimensional thermal map of the upper 2 kilometers of every ocean basin on the planet, updated every 10 days. The subsurface heat content anomaly that we described earlier in this report, the 6 months of rising temperatures in the equatorial Pacific thermocline, comes from this float network. What the Argo floats are reading in the equatorial Pacific right now is not a surface phenomenon. It is a thermal reservoir building in the water column below the level that the standard surface indices can detect directly. The reservoir is there. The floats confirm it. The JSON 3 satellite adds another dimension. It measures sea surface height, the altitude of the ocean surface relative to a reference ellipsoid, with a precision of approximately 3 centimeters. When warm water accumulates in the central and eastern equatorial Pacific, it raises the sea surface because warm water has lower density and therefore greater volume than cold water. Sea surface height anomalies in the equatorial Pacific are one of the most reliable leading indicators of El Niño strength, because the warm water pool that drives the event manifests as a visible bulge in the sea surface height record before the surface temperature index has fully responded. The current JSON 3 sea surface height data for the equatorial Pacific shows positive anomalies, elevated sea surface in the central and eastern Pacific that are consistent with the subsurface warming picture and with the early development of El Niño conditions. Together, these 3 monitoring systems, the Tau buoy array, the Argo float network, and the JSON 3 altimetry satellite, constitute the core of NOAA's ENSO early warning infrastructure. They represent approximately 40 years of scientific and political effort to build an observational system capable of detecting El Niño before its consequences are irreversible. Tonight's El Niño Watch declaration is the product of that infrastructure. The 82% probability attached to it is the product of 4 decades of monitoring data used to train and validate the numerical models that now run forecast ensembles every day. The number is not certain, but its basis is real. There is one additional monitoring signal that the current ENSO discussion has brought into focus, and it is one that has received almost no attention in the mainstream coverage of this developing event. The Madden-Julian oscillation, known as the MJO, is a pulse of enhanced atmospheric convection and rainfall that moves eastward around the tropics over a period of approximately 30 to 60 days. In its different phases, the MJO can either suppress or enhance the development of El Niño by interacting with the trade wind system. When the MJO is in phases that produce westerly wind anomalies over the western Pacific, it can trigger the kind of westerly wind bursts that accelerate the eastward propagation of subsurface Kelvin waves, adding momentum to a developing El Niño. NOAA's Climate Prediction Center noted in its May 14 discussion that the MJO had been in phases favorable to El Niño development through late May. That interaction is ongoing. The MJO continues its 30 to 60-day cycle, and its position in late May and early June will either reinforce or temporarily dampen the development signal. The monitoring window between now and June 11 includes at least one complete MJO cycle. What the MJO does in that window will be part of the data picture when the next formal discussion is issued. That is the full instrumental picture as of tonight's filing. The subsurface is warm, the surface is warming, the atmosphere is beginning to respond, the models agree, the monitoring window is open. What follows from here is a continuation of a pattern that the modern record has tracked for 140 years and the ancient archive has encoded for millennia. The pattern does not guarantee a specific outcome. It defines the envelope of possibilities. The envelope, as of the 2nd of June 2026, is skewed strongly toward a developing El Niño of moderate to strong intensity, with a meaningful probability of reaching very strong status by late 2026. We need to spend time with 3 specific historical events before we can move into the ancient record, because the modern instrumental history of El Niño is itself a form of evidence, a pattern of consequences that recurs with enough regularity to constitute a precedent. Not a certainty, a precedent. The 1997, 1998. El Niño remains the standard reference point for what a large event does to the planet. It developed with unusual speed. In early 1997, subsurface heat content in the equatorial Pacific was already anomalously high, as it is right now. By June of that year, the Niño 3.4 index had crossed the 10 degree threshold. By October, it stood above 2 degrees. By its peak in November and December, it reached approximately 4 degrees Celsius above the long-term average, the highest anomaly recorded in the modern instrumental era to that point. The consequences were distributed globally, but not evenly. In Peru and Ecuador, flooding killed more than 2,000 people and caused infrastructure damage estimated at $5 billion. In Indonesia, a drought of such severity that it enabled catastrophic forest fires burned 9 million acres and blanketed the region in a haze that killed at least 527 people directly and disrupted the respiratory health of an estimated 70 million. In East Africa, flooding associated with altered precipitation patterns killed more than 2,500 people in Kenya, Somalia, and Ethiopia. The Pacific fisheries collapsed. The Peruvian anchovy catch dropped from 7.2 million metric tons in 1996 to 7 million metric tons in 1998, and with them, the livelihoods of a fishing industry that had persisted in that coastal system for millennia. Globally, the event was associated with a significant spike in global average surface temperature in 1998 that made that year, at the time, the warmest in the instrumental record. That record did not last long. The 1982, 1983 El Niño, which preceded the 1997 event as the prior record holder, was in some ways more instructive because it arrived without adequate warning. The monitoring infrastructure that exists today did not exist in 1982. The Tropical Atmosphere Ocean Array, the network of moored buoys across the Pacific that provides real-time subsurface data, was still years from deployment. NOAA's ENSO forecast capacity was in its earliest stages. When the 1982 event began to develop, it went largely unrecognized until it was already well underway. By the time forecasters understood its scope, the consequences were already accumulating. Drought across Australia reduced agricultural output by an estimated $3 billion. Floods in Ecuador and Peru caused damage on a similar scale. Across sub-Saharan Africa, a drought linked to altered atmospheric circulation contributed to a food crisis that affected millions. Hawaii experienced its worst flooding in recorded history. The event was, in the words of the NOAA scientists who studied it afterward, a demonstration that the coupled ocean-atmosphere system could change more rapidly than existing monitoring could detect. What both of those historical events share, and what makes the current situation noteworthy, is the specific configuration of subsurface heat content that preceded them. In both 1982 and 1997, the deep equatorial Pacific was already anomalously warm before the surface index crossed the official threshold. The thermocline was already displaced downward. The wave energy was already propagating eastward. The equatorial Pacific subsurface heat content anomaly in early 2026, 6 months into its current rising trend, is comparable in structure to what the historical record shows for those two events at equivalent lead times. The agencies are not saying this event will replicate 1997. The models show a range, but the range begins at moderate and reaches very strong, and the subsurface setup that precedes the two most consequential events in the modern record is present in this one. There is one additional parallel that we want to note before moving to the ancient record, because it is the connection that most reporting misses. The Deep Ocean Warming Study published in Earth's Future in April 2026 found that the accelerating heat uptake in the ocean's deep layers has been adding to sea level rise at a rate that outpaces surface estimates. The mechanism is thermal expansion. Warm water takes up more volume than cold water, and as the deep ocean warms, it expands from below. What the study found is that this expansion has been contributing to a sea level anomaly, a component of observed sea level rise that could not be accounted for by the known contributions from ice sheet melt, glacier retreat, and thermospheric expansion of the upper ocean alone. The deep ocean has been warming faster than the models expected. That is the number that mainstream coverage has not fully reported. It is the number that will matter as El Niño's surface warming adds to a baseline that is already running above forecast. That number will matter again when we reach the fourth tradition in the ancient record section. Keep it in mind. The pattern we are about to examine is an old one, and the people who first recorded it were not working from ignorance. They were working from observation. What they observed, and how precisely some of them described it, is what the next section of tonight's report is dedicated to. The modern instrumental record of El Niño events covers approximately 140 years with any reasonable confidence, beginning with the earliest systematic Pacific Sea surface. Temperature measurements in the late 19th century, and extending back through a patchwork of ship log records, coastal tide gauge observations, and colonial-era harvest records to perhaps the mid-1700s. Beyond that, the documentary record thins, and scientists depend on proxy data, coral isotope ratios, tree ring patterns, ice core chemistry, and sediment deposits from coastal lakes that respond to the precipitation shifts El Niño produces. That proxy archive pushes the reconstructed El Niño record back through several centuries, revealing a pattern that repeats with a frequency of roughly 2 to 7 years, varying in amplitude from barely detectable to civilizationally disruptive. The civilizationally disruptive ones are the ones that left a mark on the historical record, and the historical record, across multiple independent archival traditions, logged them. The first parallel we want to examine is the European documentary record of the 17th century, specifically the extraordinary cluster of climate anomalies that researchers now call the general crisis of the 17th century. Between approximately 1620 and 1680, a period already stressed by reduced solar output, the Maunder minimum, a period of significantly reduced sunspot activity that suppressed global temperatures. The planetary climate was further destabilized by what reconstructed ENSO proxies suggest was a period of unusually frequent and intense El Niño events. The impacts were continental in scale. In China, the collapse of the Ming dynasty was preceded by a catastrophic drought in the 1630s and 1640s that destroyed the agricultural base of northern China, produced a famine that scholars estimate killed between 14 and 30 million people, and weakened the Qing transition so severely that some historians argue the climatic disruption was as consequential as any political or military factor. In the Ottoman Empire, a prolonged drought across Anatolia in the 1640s and 1650s contributed to a series of rebellions that nearly destroyed the central state. In France, crop failures in the 1640s contributed to the conditions that produced the Fronde, a series of civil conflicts that the French government spent decades recovering from. In Peru, the Spanish colonial records show a pattern of catastrophic flooding alternating with severe drought in the Andean coastal zone, the classic fingerprint of intensified ENSO variability across multiple decades of the 17th century. The documentary signature of those events is unmistakable once you know what to look for. In the Andean colonial record, Spanish governors repeatedly wrote to Madrid describing the failure of the coastal fisheries and the flooding of the lowland agricultural zones in years when the highland zones simultaneously experienced drought. That pattern, coastal flooding and highland drought, occurring simultaneously along the Pacific coast of South America, is the definitive regional fingerprint of a strong El Niño. The governors did not know what caused it. They described it as divine punishment, as the anger of the sea, as a disruption of the natural order that the land had previously maintained. They were describing, in the language available to them, a coupled ocean-atmosphere event that their instruments could not detect, but their harvests could not miss. The second parallel goes further back and carries a more specific evidentiary weight. In 1580 CE, the Potosí region of what is now Bolivia, at that time the most productive silver mining complex in the Western Hemisphere, and arguably one of the most economically significant locations on the planet, experienced a catastrophic flood. The Pelaya River, which drains through the highlands before descending toward the Pacific coastal plain, received rainfall that overwhelmed its banks and destroyed downstream infrastructure. Spanish administrative records, preserved in the Archivo General de Indias in Seville, describe the event in detail, an extraordinary rainfall event in a normally arid region, arriving in a season when rainfall was not expected. Isotopic analysis of lake sediments in the Peruvian and Bolivian highlands shows a major ENSO anomaly in that same year. The 1580 event is one of the earliest dated El Niño occurrences, supported by both documentary and proxy evidence from the same period. There is a name in the proxy record associated with the 1580 El Niño that is relevant to tonight's report. We will name it in the Ancient Traditions section because it is not a scientific name. It is the name given to this kind of event by the people who had been watching it from the Andean coastal system for far longer than Spanish colonists had been present in the Americas. That name will close the loop between the historical record and the ancient archive. Keep it available. The third parallel involves the 16th century, and it is, in terms of scale of documented consequence, among the most instructive entries in the entire instrumental and proxy record of ENSO. In 1789-1793, a prolonged and severe El Niño, one of the strongest in the reconstructed record prior to 1900, produced what historians of climate and empire have documented as a catastrophic, simultaneous global drought. The event, which the historian Mike Davis later called the first El Niño famine, in the sense of a globally synchronized agricultural collapse triggered by ENSO variability, killed between 30 million and 60 million people across 3 continents. In India, the Bengal drought and famine of 1769-1773 killed an estimated 1/3 of the population of Bengal, possibly 10 million people. In China, a drought across multiple provinces in the same ENSO cycle destroyed the agricultural output of one of the most productive agricultural systems on Earth. Across sub-Saharan Africa, the drought produced what European observers described as rivers that ran dry, lakes that vanished, and pasture lands that turned to dust. In Egypt, the Nile flood failed for multiple consecutive years in the 1780s and 1790s, producing a famine that contemporaries documented as among the worst in the country's recorded history. And in Mexico and the broader Caribbean, a drought so severe that it produced crop failures across the breadth of the colonial agricultural system contributed to the conditions that were building toward the revolutionary upheavals of the late 18th century. The synchronization of those events, their simultaneous occurrence across India, China, West Africa, Egypt, and the Americas is what distinguishes the ENSO interpretation of the late 18th century crisis from any single region explanation. No regional, political, or agricultural factor explains a simultaneous food crisis on 4 continents. The common thread is the coupled ocean-atmosphere system of the Pacific and its downstream effects on the monsoon systems of Asia, the trade wind dynamics of the Atlantic, the rainfall patterns of sub-Saharan Africa, and the Nile flood that fed Egypt. When El Niño disrupts the water circulation in the Pacific, it reaches every agricultural system that depends on predictable seasonal rainfall. The 18th century event did not discriminate by civilization, by faith, by geography. It was a planetary redistribution of rainfall, and the civilizations that happened to be in the path of the redistribution paid the price. There is a passage in the ancient record that describes exactly this kind of planetary redistribution. It does not use the term water circulation. It does not reference sea surface temperature anomalies. But the structural description it provides is precise enough in its identification of a disruption to the cycle of rains, the failure of the waters to follow their ordained path, and the consequence of that failure spreading to all the lands touched by that water, that it demands the same kind of careful attention we have just given to the historical archive. The pattern in the modern and historical record is clear, but we do not stop at the modern record. There is an older layer: tablets, manuscripts, oral traditions, documented predictions that logged events matching this signature long before our instruments existed to confirm them. That layer is what comes next. We also want to extend the historical record section before moving to the ancient archive, because there is a 4th historical parallel that we deferred, one that connects the Andean colonial record directly to the institutional development of what we now call climate science, and that demonstrates how long it took the modern world to recognize what the Andean coastal communities had understood empirically for thousands of years. In 1891, the Peruvian geographer and explorer Luis Carranza presented a paper to the Lima Geographical Society describing a warm ocean current that appeared off the northern Peruvian coast around the Christmas season in certain years, disrupting the normal cold upwelling of the Peru current, displacing the anchovy schools that supported the coastal fishery, and bringing anomalous rainfall to the desert coast. He called it the Corriente del Niño, the current of the Christ child, borrowing the name that had been in use among the coastal fishing communities for as long as those communities had existed. Carranza's paper was the first formal scientific document to use the term El Niño in the context that the modern scientific community now recognizes. But Carranza was not describing a discovery. He was describing, in the language of 19th century European geography, something that the Andean coastal communities had been watching and naming for thousands of years. The scientific literature that followed from the work of Gilbert Walker at the Indian Meteorological Department in the 1920s and 1930s, who identified the southern oscillation as the atmospheric component of what Carranza had described in the ocean, to the work of Jacob Bjerknes at UCLA in the 1960s, who first articulated the coupled ocean-atmosphere mechanism that connects the southern oscillation to sea surface temperatures in the central Pacific, was building, without knowing it, on an empirical foundation that Andean observers had laid over millennia. Gilbert Walker is worth spending a moment on because his story is instructive about what the modern monitoring infrastructure was trying to do before it had the instruments to do it properly. Walker was appointed Director General of Observatories in India in 1904, tasked with improving the prediction of the Indian monsoon, which the British colonial administration considered a matter of economic and political survival, since the failure of the monsoon meant famine, and famine in late 19th century India had been catastrophic in scope and politically destabilizing in consequence. Walker did not have satellite data. He did not have buoys. He had a network of surface weather stations whose records extended back several decades, and he had a statistical mind of unusual power. He spent years analyzing the pressure records from stations around the world and identified a seesaw pattern of atmospheric pressure between the eastern and western Pacific high. Pressure in the east, low pressure in the west, in normal years, and a reversal of that pattern in years when the monsoon failed. He called this the Southern Oscillation. He did not know what caused it. He could not see the ocean temperatures that Bjerknes would later connect to his pressure records. But he identified the atmospheric pattern with enough precision to use it as a probabilistic predictor of monsoon rainfall. Walker's work was largely forgotten for decades after his retirement, considered too abstract and statistical to be useful in an era that preferred mechanistic physical explanations. It was only when Bjerknes, working from the newly available data from the International Geophysical Year of 1957-1958, identified the ocean temperature component of Walker's Southern Oscillation, that the modern ENSO concept was assembled, a coupled system in which ocean temperature, atmospheric pressure interact in a feedback loop, each reinforcing the other, producing the planetary climate pattern that Walker had glimpsed in his pressure records half a century earlier. The complete theory of El Niño, the coupled ocean-atmosphere feedback, the role of subsurface Kelvin waves, the connection between the Pacific SST anomaly and the global teleconnections that distribute El Niño's effects to every continent, was not assembled until the 1980s and 1990s, in the aftermath of the monitoring failures of 1982 that had made the investment in theory as well as infrastructure politically possible. The modern forecasting capability that produced tonight's 82% probability figure is, in historical terms, extremely recent. The Argo network reached its design density only in the 2000s. The JASON-3 satellite was launched in 2016. The NMME forecast ensemble that generates the model consensus was not operational until 2011. What the current ENSO monitoring system can do, detect the subsurface precursors of El Niño months before the surface index crosses the threshold, generate probabilistic forecasts with lead times of 6 months or more, and communicate those forecasts through a global information infrastructure that reaches every agricultural ministry and emergency management agency on the planet would have been unimaginable to Luis Carranza in 1891, and entirely unnecessary to the Andean coastal communities who had been doing the equivalent through direct environmental observation and encoded cosmological knowledge for 4,000 years before him. That continuity from 4,000-year empirical observation to 19th century European geography to 20th century theoretical climatology to 21st century satellite monitoring is the full history of the phenomenon that NOAA's Climate Prediction Center declared under official watch on the 14th of May, 2026. The history is not merely interesting, it is directly relevant to how seriously the current watch declaration should be taken. The pattern is real, the monitoring is real, the consequences are documented across the full span of human civilization's engagement with the Pacific. When the agency speaks, it speaks with the authority of the instrumented record. When the ancient archive speaks, it speaks with the authority of the observed record. Both are saying the same thing. Before we leave the historical record entirely, there is one more entry that we want to bring forward, because it sits at the intersection of the documentary, the scientific, and the cosmological in a way that is unusual even by the standards of this field. It concerns the same Andean coastal system where El Niño was first named, and it involves a set of Spanish administrative records from the 1570s that have received attention from climate historians at the University of California, Berkeley, and from archaeologists working on the coastal settlements of pre-Columbian Peru. When the Spanish arrived on the Pacific coast of South America in the 1530s, they encountered a complex of coastal fishing communities that had been in continuous operation for at least 4,000 years. The community of Lambayeque, on the northern Peruvian coast, maintained a tradition of reading the ocean, of interpreting the signs that the sea provided about what was coming. These were not casual observations. They were systematic. The communities knew that when the frigid upwelling current that runs along the Peruvian coast, which we now call the Humboldt Current or the Peru Current, weakened, warm water from the north would spread south along the coast. They knew that when that happened, the anchovies that sustained the coastal economy would disappear from their normal depths. They knew that the rains would come to the desert coast, where rains were otherwise almost entirely absent. They knew that the rivers would flood, and they knew approximately when in the annual cycle to watch for the early signs. The Spanish administrators documented these community observations with varying degrees of care, but they documented them. In the records of the coastal corregimientos, there are descriptions of the local practice of watching for what the communities called, and the Spanish transliterated, as a warming of the sea in the vicinity of Christmas, and the consequences that were expected to follow. That 4,000-year empirical record of ENSO, the longest continuous observational record of the phenomenon anywhere in the world, is not what made the ancient traditions section of tonight's report. What made it is older than 4,000 years. The traditions we are about to examine from the Andean, Mesopotamian, Mesoamerican, and West African record, each logged in their own symbolic language, not just the occurrence of this kind of disruption, but its mechanism, the sea warming, the rain following, the order of things inverting. They logged it as cosmology. We are about to examine why. The first tradition we examine comes from the Andean coast itself, from the cosmological and ritual system of the Inca Empire and its antecedents in the pre-Columbian Andean world. It is appropriate to begin here because the El Niño phenomenon was born in this geography, named by people who lived with it, and embedded in a ceremonial calendar that was explicitly designed to track the behavior of the sea and the sky together. The Quechua term for the kind of world order disruption that a strong El Niño represents is Pachakuti. The word is formed from two roots, Pacha, which means both time and space, the underlying structure of reality, and Kuti, which means a turning or a reversal. A Pachakuti is not merely a historical upheaval or a political revolution. It is a cosmological event, the turning over of the world, the inversion of the established order of things, the moment when what was above comes below, and what was below rises. The Inca and their Andean predecessors used this concept to periodize their history. Each major upheaval, each transformation of the political and natural order was designated as a Pachakuti. The Spanish conquest was a Pachakuti. The fall of Tiwanaku was a Pachakuti. And before any of those political events, the term was used in its original cosmological sense to describe what happens when Viracocha, the creator deity of the Andean tradition, the being who emerged from the primordial waters of Lake Titicaca and ordered the world of sky and earth into its proper relationships, allows or causes the established order of the waters to reverse. In the Andean cosmological account preserved through the oral tradition that Spanish missionaries recorded in the mid-16th century, and that scholars, including Gary Urton, Sabine McCormack, and Frank Salomon, have analyzed in the modern academic literature, the relationship between the sea and the rain is understood as a created order, a set of paths established by Viracocha, along which the waters of the world flow in their correct direction. The cold water rises from the deep. The upwelling brings life to the surface. The anchovies swim in their millions. The birds feed. The guano accumulates on the islands. The fertilizer sustains the coastal agriculture. That is the proper order. But the Andean tradition also describes a state of reversal, a Pachakuti of the waters in which the cold upwelling fails. The warm water spreads south. The fish disappear. The rains fall on the desert coast. The highland rains fail, and the order Viracocha established inverts. The word for this state, the technical cosmological term, not the general word for disruption, appears in several of the colonial-era Quechua texts as a description of what the sea does when it forgets its path. What is notable for the purposes of tonight's report is not that the Andean tradition recognized El Niño 4,000 years of observation on the Pacific coast of South America would be sufficient to recognize almost anything that happened every 2 to 7 years. What is notable is the structural sophistication of the explanation. Not merely that the warm water comes, but that it represents a failure of the established order of the waters to follow their correct path, and that this failure propagates outward from the sea into the sky, from the sky into the rain, and from the rain into the land and the food and the political stability of the civilization. The Andean account describes a cascade. The modern meteorological account of El Niño's effects on global precipitation patterns describes the same cascade in different language. The observation to cosmology translation is direct in this case. The ancient Andean practitioners of the calendar system that tracked ENSO were not metaphorizing. They were recording a mechanism they had observed across multiple generations and encoded into ritual precisely because the mechanism was real enough to demand anticipation. When the signs appeared in the sea, the coastal communities performed specific rituals of appeal to Viracocha offerings at the shore, ceremonial redirections of water through irrigation systems to mirror the correct flow that the natural system was failing to maintain. These were not superstitions. They were adaptive responses to a recurring environmental disruption performed in the language available to the people performing them. The Pachakuti of the waters is documented in the colonial sources as a known, named, recurring event. The current NOAA Watch Declaration represents, in the language of the Andean Archive, the early signs of exactly such a Pachakuti arriving on schedule. The second tradition we examine tonight comes from a much older source and from a geography, an ocean, away from the Pacific coast. The Eridu Genesis is among the oldest written documents in human history. Discovered in fragments at the ancient Sumerian city of Nippur in what is now southern Iraq, written in Sumerian cuneiform on clay tablets that have been dated to approximately 1,600 BCE, based on the stratigraphy of their discovery. The text itself records a tradition that scholars believe is significantly older than the physical tablets, possibly tracing to oral traditions from the 3rd millennium BCE. From the earliest centuries of Sumerian urban civilization in the Tigris-Euphrates Delta, the Eridu Genesis describes, among other things, the creation of human civilization, the institution of kingship, and a great flood, but unlike the later Babylonian Atrahasis text or the Akkadian flood account, it describes the flood in the context of a disruption to the ordering of the waters that preceded the flood itself. The relevant passage, in the Thorkild Jacobson translation that remains the standard scholarly edition, describes a period before the flood in which the rivers do not flow in their ordained courses, in which the rains fall out of season, and in which the sea advances into land that was previously dry. The Sumerian terminology that Jacobson renders as the sea advances uses the word for the great sea, Abzu, the cosmic ocean beneath the earth, that, in Sumerian cosmology, was the source of all fresh water, the subterranean reservoir from which rivers drew their flow. When the Abzu becomes disordered, when the boundary between the sea below and the land above fails to hold, the consequence is a reversal of the proper ordering of water flood, where there should be drought, drought where there should be rain. The text describes this as a failure of the divine management of the waters, not a natural phenomenon in our modern sense, but the description of consequences, shifted precipitation, advancing seas. Disordered river flow matches the documented regional impacts of a severe El Niño on the broader climatic systems of the Middle East. The Mesopotamian world was climatically downstream from ENSO. The Indian Ocean monsoon, which drives precipitation across the Arabian Peninsula and into the Tigris-Euphrates drainage basin, is significantly modulated by ENSO. In strong El Niño years, the Indian Ocean monsoon tends to weaken, reducing rainfall across the Arabian subcontinent and into Mesopotamia, while simultaneously increasing rainfall in parts of the Mediterranean. The result is a regional precipitation pattern that the Sumerian agricultural system would have experienced as drought in its inland and highland regions and anomalous flooding its delta and coastal regions, exactly the inversion the Eridu Genesis describes as a prelude to catastrophic disruption. The Sumerian scribe who recorded this was not writing about ENSO, but the pattern of consequences he described as divine disorder maps onto the regional consequences of a strong El Niño event with enough structural precision to be noted. We note it not as proof of anything beyond the scribe's own observation. We note it because the pattern sea disorder producing precipitation inversion is described consistently across traditions that had no contact with each other and no shared vocabulary. The Andean tradition and the Sumerian tradition arrived at structurally similar descriptions of a structurally similar event through independent observation over millennia of accumulated experience with a climate system that operates on planetary scales too large for any single civilization to comprehend as a unified mechanism. What each civilization saw was its local manifestation of the same global disruption. What each encoded in its cosmological archive was the knowledge that the disruption recurs, that its signs can be read in the behavior of the sea, and that the consequences will follow in a predictable pattern once the sea has made its announcement. We are currently in the moment of announcement. The third tradition we examine tonight comes from the ceremonial calendar system of the Aztec civilization, and within that system, from a specific intersection of cosmological accounts that bears directly on the question of what happens when the rains fail to follow their established path. The Aztec ritual calendar, the Tonal Powali, was a 260-day sacred cycle that ran continuously through the Aztec year, intersecting with the 365-day solar calendar to produce a 5-2-year cycle of unique date combinations. Within the Tonal Powali, each day was associated with a deity, and each deity carried specific responsibilities in the maintenance of the cosmic order. Two of the most important deities in the Aztec system for the question of water and rain were Tlaloc, the rain deity, one of the oldest deities in the Mesoamerican tradition, predating the Aztec by at least 2 millennia, found in the archaeological record at Teotihuacan in the 1st century CE, and attributed to even earlier traditions, and Cipactli, the primordial sea monster, from whose body the world was created. Tlaloc's relationship to agricultural productivity was absolute and well documented in the Aztec codices, including the Codex Borgia and the Florentine Codex recorded by the Franciscan friar Bernardino de Sahagún in the 16th century. Tlaloc was the provider of necessary rain, but the Aztec tradition was explicit that Tlaloc's provision was not guaranteed. In years when Tlaloc withheld the rains, when the ceremonial calendar markers associated with moisture and agricultural fertility were absent or reversed, the consequence was drought. And in years when Tlaloc sent rain in excess, when the calendar markers of the wet season extended beyond their proper duration or arrived at the wrong time, the consequence was flood. The Aztec tradition did not explain this in terms of a single cause. It explained it in terms of cosmic balance, the proper relationship between the elements that had been established by the gods and that could be disrupted by ritual failure, by moral transgression, or by the approach of a cosmic transition period. What is specifically relevant to El Niño is the Aztec tradition's understanding of the relationship between the Pacific Ocean and the rain system. The Aztec Empire's heartland in the Mexican highlands is climatically positioned where the effects of ENSO are among the most pronounced anywhere in the North American continent. In strong El Niño years, Mexico typically experiences a weakening of its summer monsoon, the North American monsoon system, which reduces rainfall across the Mexican highlands and produces drought. Conditions in the agricultural core of central Mexico. The pre-Columbian agricultural collapse events that Spanish colonial sources describe as associated with drought in central Mexico cluster, when their dates can be determined, in years that proxy ENSO reconstructions associate with strong El Niño events. The Aztec calendar system was, among other things, a rainfall prediction system. Its elaborate cycle of deity associations and ceremonial obligations was designed, at a practical level, to anticipate and prepare for the disruptions to agricultural rainfall that a civilization dependent on maize could not survive without prediction. The Codex Borgia's sequence of Tlaloc imagery, which depicts the rain deity in both his benevolent and withholding aspects, is explicitly associated with specific calendar periods that, when mapped against reconstructed precipitation data for central Mexico, show a correlation between the withholding aspects and drought periods that exceeds what would be expected from random calendar structure. The scholars Cecilia Klein at UCLA and Anthony Aveni at Colgate University have each analyzed the astronomical and calendrical structure of the Aztec ritual system and found evidence that it encoded observational knowledge of large-scale climate variability that the modern study of ENSO has subsequently confirmed as real. The calendar was not merely ceremonial, it was predictive, and its predictions about the failure of the rains, encoded in the imagery of a deity who could withhold as readily as he could provide, were based on a pattern of observation as long as the civilization itself. The answer to the question planted at the beginning of this report's briefing section, what is the number in the NOAA data that most reports have not flagged, is this: the Niño et plus 2 index. The eastern equatorial Pacific, closest to the South American coast, the coast where El Niño was first named and first observed, already stands at +1 degrees Celsius. It is the leading edge of what the rest of the Pacific Basin is still building toward. The Andean tradition recognized that the warming always arrives at the coast first, before it spreads, before the rains follow, before the highland drought begins. The number is in the eastern Pacific. The Andean observers knew 4,000 years ago that the eastern Pacific is where you look first. The instruments agree. The fourth and final tradition we examine tonight comes from West Africa, and it is the one that has received the least attention in any discussion of El Niño cosmology, which makes the structural precision of its account of the deep sea all the more striking. The Yoruba tradition of southwestern Nigeria and its diaspora is one of the richest cosmological systems surviving from the pre-colonial African world. Its pantheon of orishas, divine beings who govern specific domains of the natural and human world, includes Olokun, the orisha of the deep sea and the unfathomable depths of the ocean. Olokun is not simply a sea deity in the way that Poseidon is a sea deity governing waves and storms and the surface behavior of the ocean. Olokun governs what is beneath the surface. The name itself, in Yoruba, means the owner of the ocean, but the aspect of ownership is specifically the depths, the part of the ocean that no human instrument had yet reached, the part that holds what the sea does not reveal at its surface. The Yoruba theological tradition surrounding Olokun, documented in the scholarly literature by practitioners and scholars, including Babatunde Lawal at Virginia Commonwealth University and William Bascom, whose foundational research on Yoruba religion was conducted in the 1930s and 1940s, describes Olokun as the keeper of wealth, of the resources buried in the deep, and simultaneously as a being of profound instability, one who, when displeased or disturbed, is capable of flooding the land, disrupting the waters, and overturning the relationship between the sea and the shore. The Yoruba tradition is explicit that Olokun's domain is not merely the surface of the sea, but the thermal layers beneath it, the deep water that surfaces in upwelling, the cold water that moderates the coastal temperature, the warm water that, when it rises inappropriately, disrupts the coastal ecosystem and drives the fish away. The orishas in the Yoruba tradition are not metaphorical. They govern real phenomena. Olokun governs the real behavior of the deep ocean. And the Yoruba tradition's understanding that Olokun's disruption produces a specific pattern of consequences, the flooding of coastal lands, the failure of the fishery, the invasion of warm water into cold water zones, is structurally identical to the documented consequences of an El Niño event on the West African coast. West Africa's rainfall patterns, particularly in the Sahel region and along the Gulf of Guinea coast are significantly modulated by the Indian Ocean SST anomalies that accompany El Niño. In strong El Niño years, the West African monsoon weakens, reducing rainfall across the Sahel and contributing to drought conditions in the agricultural heartland of Western Africa. The coastal fisheries of the Gulf of Guinea, which depend on upwelling dynamics that are disturbed by the atmospheric circulation shifts that El Niño produces, are affected in documented ways. The Yoruba tradition encoded the knowledge that the deep ocean governs these outcomes. Olokun's domain is the thermal structure of the deep sea. The modern study of ENSO has confirmed that the deep ocean is the reservoir. The 6 months of rising subsurface temperatures that preceded the current El Niño watch are the physical reality that the Yoruba theological tradition describes as Olokun's domain entering a state of disturbance. The deep ocean warming study published in Earth's Future in April 2026, the one that found that accelerating deep ocean heat uptake is driving an anomaly in global sea level rise, is describing, in modern scientific language, a change in Olokun's territory. Not because the Yoruba were right about theology, because they were right about observation. The deep ocean matters. What happens below the surface of the sea determines what happens on land. Olokun's governance of the depths is a cosmological encoding of a physical reality that the modern monitoring grid of Argo floats and moored buoys and satellite altimetry has now quantified. The description recorded is structurally identical to the data on the board tonight. The pattern is on the record in both places. The language used is precise enough to be notable. The data is in the record. The interpretation belongs to you. We want to return to each of these 4 traditions individually and extend the comparison because the structural parallels we have identified are not shallow. They reward closer examination. The precision of each tradition's account of what a warming sea does to the land and the sky is the kind of precision that can only come from observation across generations. Beginning with the Andean tradition and the concept of Pachakuti, the scholarly literature on this concept is not small. The work of Gary Urton, particularly his study of the Quechua concept of Pacha in the context of Andean cosmological time, establishes that the Pachakuti was not experienced as an exceptional rupture, but as a recognized phase of the cosmic cycle. Each of the great Pachakutis that the Inca identified in their historical periodization was associated with a change in the natural order, a drought, a flood, a failure of the agricultural system that forced a reorganization of human society. The Inca calendar did not merely track time. It tracked the relationship between time and the behavior of the natural world, and it anticipated that the natural world would periodically invert its normal patterns in ways that required specific human responses. The Inti Raymi, the festival of the sun, was timed to coincide with the winter solstice in the southern hemisphere, when the sun's trajectory reaches its northernmost point and begins its return. The ritual functioned as a form of cosmological maintenance, a ceremonial act of reasserting the proper order of the solar and terrestrial system. But the rituals associated with Viracocha, the water deity, had a different temporal character. They were not fixed to a single annual date. They were responsive. They were performed when the signs appeared in the sea, when the coastal upwelling weakened, when the water changed its temperature, when the birds that fed on the anchovies dispersed from their normal feeding grounds. The Andean ritual system had, in other words, a monitoring function as well as a ceremonial one. It was watching the same signals that NOAA is watching tonight. The 1580 El Niño we mentioned in the historical section has a specific name in the Andean oral tradition. The communities of the northern Peruvian coast described major El Niño years as years when the sea sent its messenger a warming current that moved south along the coast ahead of the main event, arriving like a scout before an army. The Spanish missionaries who recorded this tradition in the 1570s and 1580s were baffled by the ecological precision of the local prediction system. The coastal communities could identify years in which the warming current was unusually strong, and they associated those years with what the Spanish transcribed as a reversal of the world, a description that matches the Quechua concept of Pachakuti with precision. In 1580, when the major El Niño arrived and the floods devastated the coastal agricultural zones, the coastal communities had already performed their response rituals. They had moved their fishing operations, adjusted their agricultural planting in the highland zones, and appealed to the appropriate deities. The Spanish administrators noted with some surprise that the indigenous communities had been better prepared than the colonial infrastructure, which had no comparable early warning system. We note this not to romanticize the pre-colonial past, but because the observational precision it represents is directly relevant to the current monitoring picture. The Andean coastal communities, through 4,000 years of continuous observation, had developed an empirical understanding of El Niño's lead indicators, the specific signals in the sea and in the coastal ecosystem that appeared before the main event, that in some respects anticipated the modern concept of the ENSO early warning system. NOAA's current watch declaration is, in structural terms, exactly the kind of early warning signal the Andean tradition encoded in ritual form. The sea has sent its messenger. The Niño 1+2 index at +1 degrees Celsius is the warming current moving south along the metaphorical coast of the planetary temperature record. The question, as it was in 1580, is what follows. Returning to the Sumerian tradition and the Eridu Genesis, the deeper context of this text is important for understanding what the Sumerian scribes understood themselves to be. Documenting the Eridu Genesis was not written as a story. It was written as a cosmological account of the origin of the world order and the conditions that could disrupt it. The Sumerians understood the world as a divinely managed system, each component of the natural order assigned to a specific divine manager who was responsible for maintaining its proper function. The sea was managed by Enki, the god of wisdom, fresh water, and the Abzu, the subterranean cosmic ocean. The rains were managed by An, the sky god. The agricultural fertility of the land was managed by Enlil, the god of wind and storms. When disaster occurred, when the rains failed, when the rivers flooded their banks, when the sea advanced into agricultural land, the Sumerian interpretation was that one or more of these divine managers had either failed in their function or had deliberately disrupted the system. What is striking about the Eridu Genesis's account of the pre-flood period is its description of a sequence, not a single catastrophe, but a series of deteriorating conditions that preceded the flood itself. The rains fell out of season. The rivers did not follow their ordained courses. The sea behaved abnormally. These are described in the text as signs that the divine management of the water system had entered a state of disruption, and that this disruption would culminate in a larger event. The Sumerian scribes were describing a cascading failure, a system in which the disruption of one element of the water cycle propagated into disruptions of the others. That is precisely what a strong El Niño does to the global water cycle. It disrupts the water circulation, which disrupts the trade winds, which disrupts the monsoon systems, which disrupts the precipitation patterns of Asia, Africa, and the Americas in ways that compound each other. The cascade begins in the Pacific and propagates outward through the atmospheric teleconnections that connect the tropical Pacific to every other climate system on the planet. The Sumerian scribes did not have access to the Pacific. Their knowledge of El Niño as a Pacific phenomenon was zero. But their knowledge of the consequences of a global disruption to the water cycle, the specific pattern of out-of-season rains, abnormal river behavior, and advancing seas was encoded in the oldest written document in which that pattern appears. The pattern is not localized to Mesopotamia. It is the Mesopotamian manifestation of a global disruption that has a Pacific origin. The scribes saw the local expression of a planetary pattern and described it with enough precision that their description maps onto the modern scientific account. We want to be careful here about what we are and are not claiming. We are not claiming that the Sumerian scribes knew about El Niño. We are claiming that they observed the downstream consequences of a large ENSO event on the climate of the Middle East with enough precision to encode those consequences in a cosmological text that has survived for 3,500 years. The observation was real. The encoding was systematic. The survival across 3 millennia of human history suggests that the people who maintained this text across that period considered its content sufficiently important to preserve. We do not know everything about why they considered it important. We know what the text says. The text says that the water system can enter a state of disorder, that the signs of this disorder appear in the behavior of the sea and the sky before the main disruption arrives, and that the consequences of the disorder affect the agricultural system of the civilized world. Tonight, the monitoring instruments of NOAA and the International Research Institute confirm that the water system has entered a state of transition. The signs are in the sea and the sky. The NSO diagnostic discussion is scheduled for June 11. What follows from that date will either confirm the arrival of El Niño conditions or describe what has intervened to delay them. The Sumerian archive suggests that when the signs are this clear, intervention rarely delays the main event. We continue to monitor. The Aztec tradition's Tlaloc imagery warrants one additional observation that the scholarly literature on Mesoamerican astronomy makes available. The work of Anthony Aveni at Colgate University has demonstrated that the positioning of certain Aztec temples, including the Templo Mayor in Tenochtitlan, the great double temple that served as the ritual center of the Aztec capital, was oriented to align with astronomical events associated with the onset of the rainy season and the potential disruption of that onset. The Templo Mayor is a double structure. One side is dedicated to Huitzilopochtli, the solar war deity, and the other to Tlaloc, the rain deity. The Tlaloc side is oriented toward the east, toward the sunrise, at specific points in the agricultural calendar. But the specific sunrise alignments associated with Tlaloc are not random. They coincide with a period in the Aztec agricultural calendar when the rains should begin, and the ritual emphasis of the Tlaloc ceremonies during this period was explicitly on coaxing the rains into their proper timing and preventing them from arriving late or failing to arrive at all. The Aztec priestly tradition knew that the rains could fail. The elaborate ceremonial infrastructure around Tlaloc, including the child sacrifices documented in the colonial sources, which the Aztec performed specifically in years when drought threatened the agricultural season, because the tears of children were believed to call forth the rains, reflects the existential weight that a society dependent on seasonal precipitation placed on the reliability of the monsoon system. In a strong El Niño year, the Mexican monsoon weakens. The rains arrive late or fail entirely. The Aztec priestly class was performing emergency rituals in response to exactly the climate pattern that NOAA now predicts will recur in 2026 with an 82% probability. Their rituals were the pre-scientific equivalent of the agency bulletin. Both are attempts to anticipate, prepare for, and respond to a planetary climate disruption whose signs can be read before its full consequences arrive. The 82% probability of El Niño development in May through July 2026 has its Aztec equivalent in the priestly reading of the tonal Powali that preceded a drought year, a reading that identified specific calendar markers associated with rain failure and alerted the agricultural community to prepare. The Aztec system encoded its probabilistic knowledge in ceremonial language. The modern forecasting system encodes its probabilistic knowledge in percentage probabilities. Both are communicating the same information to the communities that depend on them. The rains may not come on time. Prepare accordingly. And returning finally to Olokun and the Yoruba tradition, there is a specific aspect of the Olokun tradition that we have not yet addressed, and it is perhaps the most precise parallel to the current monitoring picture. The Yoruba tradition holds that Olokun's domain is specifically the part of the ocean that cannot be seen, the deep, the dark, the thermal layers below the photic zone. The theological significance of this invisibility is central to the tradition. Olokun is not the god of the ocean you can observe. Olokun governs what is hidden beneath the observable surface. In the context of ENSO monitoring, this distinction is precisely significant. The surface temperature anomaly that NOAA uses to define El Niño conditions, the Niño 3.4 index, is a surface measurement. It is what can be observed from above. But the phenomenon that drives El Niño is subsurface. The warm water that powers El Niño develops below the surface, in the thermal structure of the equatorial thermocline, propagating eastward as Kelvin waves in the interior of the ocean before it rises to the surface and becomes visible to the standard index. The Argo float network, which currently has approximately 3,900 floats scattered across the global ocean, each diving to 2,000 meters and rising to transmit its temperature and salinity data every 10 days, is the modern monitoring equivalent of what Olokun governs. The floats read the deep. Their data is what NOAA uses to track the subsurface heat content that the standard surface index cannot capture alone. The Deep Ocean Warming Study that found accelerating heat uptake below 700 meters is a study about Olokun's domain, about the part of the ocean that is not visible from the surface and whose changes propagate upward into the observable world with a delay that makes them harder to predict and harder to attribute once they arrive. The Yoruba tradition understood, without instruments, that the deep ocean has its own governance, its own behavior, and that disruptions in the deep eventually become visible at the surface in ways that cannot be fully anticipated from surface observation alone. That understanding is structurally correct. The modern study of ENSO has confirmed it. The deep Pacific has been warming for 6 consecutive months. The subsurface anomaly will manifest at the surface. It is already beginning to do so. Olokun's territory is in motion. There is a final number we want to place on the record before we move to the closing section tonight. The equatorial Pacific heat content anomaly, the integrated measure of how much excess thermal energy is stored in the upper 300 meters of the equatorial Pacific, measured in units of zettajoules, stood in May 2026 at a level that is elevated relative to the 1,991-2020 baseline, in a manner consistent with the setup seen before the 1997-2015 events at comparable lead times. This is the number that most reporting has not carried. It is the number that the Andean tradition's concept of the messenger current anticipated. The deep heat that arrives before the surface index confirms it. By the time the June 11 ENSO discussion is issued, that subsurface heat content number will have either remained elevated, confirming the case for a strong or very strong event, or it will have begun to discharge, which would push the forecast toward moderate. As of the filing of tonight's report, the trajectory is upward. The data is in the record. The interpretation belongs to you. There is one more dimension of the ancient record that we have not fully developed, and it concerns the specific geography of tonight's event in the context of the traditions we have examined. Each of the 4 traditions we covered, Andean, Sumerian, Aztec, and Yoruba, was geographically positioned in a specific relationship to the El Niño phenomenon, and that geographic relationship shaped what each tradition saw, what it encoded, and what it chose to emphasize in its cosmological account. The Andean tradition sat closest to the source. The Pacific coast of South America is where El Niño originates, where the warming first becomes visible at the surface, where the upwelling first weakens, where the anchovies first disappear. The Andean traditions of the Peru-Bolivia region are therefore El Niño traditions in a direct sense. They observed the phenomenon at its origin point, before it had propagated outward to affect other climate systems. Their cosmological encoding of the event reflects this proximity. The Pachakuti of the waters, in the Andean account, is a local event with global consequences, but the local expression is what the tradition encoded first. The sea changes here. The rain follows here. The fish leave here. The downstream effects on Asia, Africa, and North America are not part of the Andean cosmological account, not because the Andean tradition was unaware that the world extended beyond its coast, but because what they could observe directly was the local origin event. The Sumerian tradition, by contrast, sat at the far downstream end of El Niño's reach. The Tigris-Euphrates Delta is approximately 15,000 kilometers from the equatorial Pacific, separated from the origin event by the full width of the Pacific Ocean, the Southeast Asian landmass, the Indian Ocean, and the Arabian Peninsula. What the Sumerian tradition observed was not the warming sea. It was the consequence of the warming sea on the Indian Ocean monsoon, the failure of rainfall in Mesopotamia's upstream catchments, the anomalous flooding of the delta region, the simultaneous disruption of the agricultural zones that fed Sumerian civilization. The Sumerian cosmological encoding of a disruption to the water order is therefore a downstream encoding, a description of El Niño's consequences at maximum distance from its source, without any knowledge of or connection to the source event. The Sumerian scribes were watching the final manifestation of a planetary process whose origin was as far away from them as it is possible to be and still live on the same planet. This distinction matters because it establishes the geographic reach of the pattern that both traditions independently documented. The Andean tradition logged the origin, the Sumerian tradition logged the consequence. They are describing, from opposite ends of the planet, the same event. This is what atmospheric teleconnections look like from the inside of human history. Two civilizations, separated by 15,000 kilometers and multiple independent cultural and linguistic traditions, each encoding in their cosmological archive a version of the same planetary disruption to the water cycle. That independent encoding from opposite geographic poles of the same phenomenon is not what you would expect from coincidence. It is what you would expect from observation of a real pattern. The Aztec tradition occupies a middle position geographically between the Andean origin and the Sumerian downstream consequence. Central Mexico is within the El Niño influence zone for the North American monsoon. The Aztec heartland experiences El Niño primarily through the weakening of its summer monsoon rainfall, a consequence that is closer to the source than Mesopotamia's response, but more removed from the direct sea surface signal than the Andean coast. The Aztec ceremonial calendar's elaborate rain deity architecture reflects this middle-distance relationship. The rains can come, but their arrival is conditional, their timing uncertain, their adequacy never guaranteed. The ceremonial infrastructure around Tlaloc is the social technology of a civilization that has learned to live with ENSO variability at an intermediate distance from the origin. Event. The Yoruba tradition sits at the furthest remove from the Pacific in terms of oceanic connectivity. West Africa's climate is driven primarily by the Indian Ocean and the Atlantic, with ENSO influences arriving through atmospheric teleconnections rather than direct oceanic pathways. But the Yoruba tradition's cosmological focus on the deep ocean, on the thermal layers below the surface that govern what eventually appears at the surface, is structurally the most sophisticated of the four accounts we have examined. It captures not the origin or the consequence, but the mechanism, the hidden thermal structure of the ocean that underlies all surface-level events. Olokun governs what cannot be seen. The current ENSO monitoring infrastructure devotes its most significant technical investment, the Argo Float Network, the moored TAO buoys, the JSON, 3 altimetry satellite, to measuring exactly what cannot be seen at the surface. The Yoruba tradition was, in cosmological terms, ahead of the instrumental observation curve. These four traditions, taken together, constitute a global observational record of El Niño distributed across the full geographic footprint of the event's influence. Each tradition encoded what it could see. Together, they encode the full picture. The modern monitoring network covers the same footprint from the equatorial Pacific origin to the downstream consequences in Asia, Africa, and the Americas, and it reads the same signal that each of these traditions, across thousands of years of independent observation, recognized as a recurring disruption to the planetary water system. The convergence is not accidental. The phenomenon is real. The archive is consistent. The instruments confirm it. We want to note one more thing before we move to the closing section. The question this report committed to answering at the beginning of the briefing was about a specific number in the NOAA data that most coverage has not reported. That number is the Niño 1+2 index at +1 degrees Celsius. We have now answered that question fully. The eastern equatorial Pacific, closest to the Andean coast where El Niño was first named and first observed, is already warming significantly ahead of the central index that most reporting focuses on. The Andean tradition knew to watch the eastern coast first. The modern instrument array confirms the Andean tradition's instinct. The number is there. It has been there since the last weekly index update. Most coverage did not cite it because most coverage focuses on the Niño 3.4 index, which has not yet crossed the threshold. But the 1+2 index is the leading edge. It is what moved first in 1997 and in 1982. It is moving first now. That number will matter as the event develops. The agencies are watching it. We have reported it. There is a specific element of the Yoruba Olokun tradition that we want to return to because it addresses something that no other tradition in tonight's report covers explicitly. And it is the element that is most precisely resonant with the deep ocean warming study published in Earth's Future in April 2026. In the Yoruba theological system, Olokun is described in some regional variants of the tradition as a deity of ambiguous nature, neither fully calm nor fully wrathful, but oscillating between states of peace and states of upheaval. The theological literature on Olokun, including the work of the Yoruba scholar Wande Abimbola, who has spent decades documenting the Ifa oral corpus that contains the most detailed Yoruba cosmological accounts, describes Olokun's peaceful state as the deep ocean in equilibrium, the waters in their proper thermal relationship, cold at the surface where the upwelling runs, warm in the deep where the heat accumulates slowly. And it describes Olokun's disturbed state as an inversion of that thermal relationship, the deep becoming restless, the warmth rising where it should remain buried, the boundary between the surface world and the deep world becoming permeable. In modern oceanographic language, a thermocline disruption, a warming of the deep that propagates upward, which is precisely what the Casanave et al. Study in Earth's Future described, accelerating heat uptake in the deep ocean below 700 meters, rising through the water column, contributing to sea level rise at rates that exceed the surface model's prior estimates. Olokun's disturbed state is the deep ocean in a condition of excess thermal energy. The tradition described this, the study confirmed it. Both are describing the same physical reality in different registers of knowledge. We file both. The Bureau's position on the relationship between the ancient record and the scientific record is unchanged from the first report filed on this channel, and it will not change. We do not claim that the ancient traditions predicted ENSO. We claim that they observed it with the instruments available to them, across the generations of observation available to them, and encoded what they saw with enough precision that the encoding remains structurally recognizable to anyone who also knows the scientific account. That structural recognition is the value of the ancient archive, not prophecy, observation, the oldest kind of monitoring we have. We want to spend additional time with the closing observations because the consequence picture for a strong or very strong 2026 El Nino extends well beyond the 6 monitoring signals we have already identified, and the Bureau's role is to file what is in the record, not to summarize and move on. The Indian subcontinent is the most populous agricultural system on the planet that is directly and strongly affected by El Nino. The India Meteorological Department, which issues its monsoon forecast each April for the June through September rainy season, issued its 2026 forecast in late April before NOAA had formally declared the El Nino watch. The IMD's forecast already incorporated the ENSO model ensemble output and flagged below normal monsoon probability for the 2026 season. In strong El Nino years, the Indian summer monsoon is statistically suppressed, not in every year and not in every region of India, but with a frequency that is high enough to drive the IMD's seasonal forecast probability downward. The mechanism is the same Walker circulation disruption that affects every other monsoon system on the planet. El Nino warms the central and eastern Pacific, which alters the large-scale tropical atmospheric circulation, which weakens the pressure gradient that drives moisture from the Arabian Sea and Bay of Bengal into the Indian subcontinent during the summer months. The consequence of a weakened Indian monsoon is not merely agricultural inconvenience. India has the second largest population of any country on Earth, and its agricultural system, while substantially more resilient than it was in the 19th century, when ENSO-associated monsoon failures killed tens of millions, remains dependent on adequate seasonal rainfall across vast regions that have no alternative water source. The current ENSO development is being watched by the IMD with the same attention that NOAA's Climate Prediction Center is giving it. The Australian Bureau of Meteorology maintains its own ENSO monitoring program and issues regular ENSO outlooks that feed into Australia's seasonal forecast system. Australia is among the most ENSO-sensitive landmasses on the planet. Its eastern agricultural zones experience drought in strong El Niño years, with a regularity that makes ENSO the single most important predictive variable in Australian seasonal forecasting. The Australian Bureau's ENSO outlook as of late May 2026 flags elevated El Niño probability in alignment with NOAA's assessment. In 2019-2020, an El Niño-influenced drought, not a full strong El Niño, but a positive ENSO tendency during a period of anomalous warming contributed to the conditions that produced the Black Summer bushfires, which burned approximately 18.6 million hectares across eastern Australia and killed or displaced approximately 3 billion animals. The current ENSO development is not 2019. The pattern may not replicate, but the monitoring agencies responsible for Australian agricultural and fire risk planning are filing their own ENSO watch adjustments. The Atlantic hurricane season is inversely correlated with El Niño. In strong El Niño years, increased upper-level wind shear over the tropical Atlantic suppresses hurricane formation and intensity. The NOAA National Hurricane Center's 2026 Atlantic hurricane season outlook was issued on the 22nd of May 2026 and incorporated the El Niño Watch declaration in its probabilistic assessment. The outlook called for a near-normal to below-normal season which, given the record-setting 2024 and 2025 seasons, would represent a significant change from the current multi-year trend. This is one of the few beneficial effects of El Niño from a direct human safety perspective. The suppression of Atlantic hurricane activity in strong El Niño years is well documented and represents a real reduction in storm risk for the U.S. Gulf and East Coasts, the Caribbean, and Mexico's Atlantic coast. The situation is reversed in the Pacific. El Niño typically enhances hurricane known as typhoon activity in the central and eastern North Pacific, and it shifts the development zone of western Pacific typhoons further east than normal. This has implications for Hawaii, which sits in a zone that sees elevated tropical cyclone risk in El Niño years, and for the populations of the Central Pacific Island nations, Kiribati, the Marshall Islands, the Federated States of Micronesia, that are exposed to the shifted typhoon track. In sub-Saharan Africa, the regional consequences of El Niño vary by location. Eastern Africa, Ethiopia, Somalia, Kenya tends to receive above normal rainfall in El Niño years, as the Indian Ocean SST pattern associated with El Niño shifts moisture patterns across the Western Indian Ocean. Southern Africa, by contrast, tends to experience drought in El Niño years, with Zimbabwe, Zambia, Mozambique, and South Africa experiencing below normal rainfall across their summer growing seasons. The 2015-2016 El Niño produced a severe drought across southern Africa that required emergency food assistance for approximately 40 million people across the region. If the 2026 event reaches comparable strength, the same regions are in the same vulnerability window. Each of these regional consequence profiles is documented in the monitoring records of the relevant national meteorological agencies. Each of them represents a lived experience record of El Niño's reach the same planetary disruption that the Andean tradition encoded as Pachakuti, that the Sumerian tradition encoded as a failure of the divine water management, that the Aztec tradition encoded in the withholding aspect of Tlaloc, and that the Yoruba tradition encoded in the disturbance of Olokun's deep domain, playing out in specific agricultural systems, specific water resources, specific human populations that are in the forecast envelope right now. The data is on the record across all of these systems, in all of these regions, in all of these archives, The interpretation of what it means that a planetary climate disruption of this scale arrives on the schedule it has always kept, and that human civilizations across 4,000 years of independent observation developed cosmological systems to track and anticipate it belongs to you. We continue to monitor. As this report is filed on the evening of the 2nd of June 2026, the instruments are running. The Argo Float Network continues its cycling through the deep equatorial Pacific, descending and ascending, reading temperature and salinity at depths the human eye cannot reach. The Tau, Triton array of moored buoys, sends its continuous surface and subsurface temperature data to NOAA in real time. The Copernicus satellite constellation of the European Space Agency maintains its radar altimetry record of sea surface height, a proxy for thermal expansion and subsurface heat, content with a precision that can detect changes of millimeters. The Jason, 3 satellite, operating in coordination with Copernicus, tracks the same signal. The GOES East and GOES West geostationary satellites monitor the cloud patterns and convective activity across the Pacific Basin. All of this infrastructure is watching the same phenomenon we have spent this report examining. The specific things to watch between now and the 11th of June 2026, the date of the next ENSO diagnostic discussion, are these. The weekly Niño 3.4 index, it currently stands at plus 0.4 degrees Celsius. If it crosses plus 0.5 degrees and sustains that level for a 3-month period, NOAA will issue an El Niño advisory rather than a watch, signaling the formal onset of El Niño conditions. Watch for the weekly update, which NOAA releases every Thursday. The weekly Niño 1+2 index. It currently stands at plus 1 degrees Celsius, significantly above the Central Pacific indices. Sustained movement above plus 1.5 degrees in the Eastern Pacific would reinforce the case for a rapid onset strong event and would be consistent with the historical precursor pattern seen before 1997. The subsurface heat content anomaly in the equatorial Pacific. This is tracked through the TAO Triton array and displayed on NOAA's Pacific Marine Environmental Laboratory website. Continued positive anomaly through June will lock in the warm water reservoir that powers the surface event. The westerly windburst pattern in the western equatorial Pacific. Windbursts are the atmospheric trigger that can accelerate the eastward propagation of Kelvin waves. If westerly wind anomalies over the western Pacific persist and strengthen through May and early June, they will act as an accelerant for surface warming in the central and eastern Pacific. The NOAA Climate Prediction Center's weekly discussion tracks this signal. And finally, the North American monsoon initialization. By late June, the first moisture from the Gulf of California and the eastern tropical Pacific should be pushing northward into Arizona and New Mexico, initiating the North American monsoon. In strong El Niño years, this initialization is often delayed, leading to a late start to the monsoon season and below normal rainfall across the southwestern United States and northwestern Mexico in the early summer months. Watch the monsoon season start date as a real-world confirmation of the model forecasts. The annual ENSO cycle is not finished. The event that is forming in the Pacific right now will trace its consequences through 2026 and into 2027 before the next La Niña phase is expected to assert itself. The agricultural cycles of central Mexico, the monsoon forecast for the Indian subcontinent, the hurricane season outlook for the Atlantic, all of these are downstream products of the decision the Pacific is making right now about its temperature. The agencies that monitor those downstream systems, NOAA, the India Meteorological Department, the World Meteorological Organization, are all watching the same upstream signal. What we have examined tonight in the ancient record is the depth of the human archive of this signal, 4,000 years on the Andean coast, 3,500 years in the Sumerian clay, 2,000 years in the Aztec ceremonial calendar, and an unquantified span of generations in the Yoruba oral tradition of West Africa. In each case, the tradition encoded not merely the occurrence of the event, but its mechanism, the sea's behavior preceding the sky's behavior, the deep water preceding the surface, the Eastern Pacific anomaly preceding the Central Pacific Index. Each tradition arrived at this structural understanding independently, through observation across enough generations to identify the pattern. The pattern is real. The archive is consistent. The current monitoring data is aligned with the pattern these traditions describe. The Bureau does not speculate about what this means for the event that is developing. The models assign probabilities. The agencies issue advisories. The proxies from the historical record provide precedent. What the ancient archive provides is something the instrumental record alone cannot. The knowledge that the people who lived closest to this phenomenon, and for the longest time, considered it important enough to encode at the center of their cosmological systems. They were not wrong to do so. They were right about the observation. They encoded it in the language available to them. We encode it tonight in the language available to us. If what you heard in tonight's report, the cross-referencing of the NOAA monitoring data against 4 independent archival traditions, each of which encoded a version of the same planetary pattern, is the kind of reporting you look for when you sit down at the end of the day, then subscribe. We file every night. There is no summary from us that replaces the full report. The full report is the thing, the data, the historical record, the ancient archive, and the analytical patience to connect them across the distance of time. Other channels cover the event. We cover the pattern. The pattern is what other coverage does not reach. If you found tonight's report useful, share it with someone who would want to know what is actually in the file, not just the headline, but the depth beneath it. And if there is a region, an event, a tradition, or a monitoring signal you want this bureau to examine in a future report, leave it in the comments. The file stays open. The research is ongoing. The next discussion is scheduled. We continue to monitor. We will report again at last light. One more element warrants its place in tonight's record before the closing section completes. The Intergovernmental Panel on Climate Change's 6th Assessment Report, published between 2021 and 2022, noted that ENSO variability, both the frequency and the intensity of El Niño and La Niña events, is expected to increase under continued greenhouse gas forcing. The mechanism is straightforward. A warmer baseline ocean provides more thermal energy for El Niño events to draw on, and a warmer atmosphere can hold more moisture, which means that the precipitation anomalies El Niño produces, the floods where El Niño brings rain, the droughts where it withholds rain, will be more intense than they would have been on a cooler baseline. The 2026 El Niño is not occurring in a climate system identical to the one that produced the 1997 or 1983 events. The background temperature is higher. The available moisture in the atmosphere is greater. The agricultural and infrastructure systems that will experience its consequences are operating on the same accumulated vulnerability that those prior events left behind. The IPCC projection is not a prediction for any specific event. It is a probabilistic statement about the direction of the trend. The trend, across the full span of the modern monitoring record, is consistent with that statement. The 2026 event, whatever its ultimate magnitude, arrives in that context. The agencies are watching, the Bureau is monitoring, the record is open,